Okay, we're back with Review Exam 2 Part 6, and we're doing 9C. Okay, so we have f of x is equal to x squared minus 16 over x minus 5. And we're going to see where it's increasing and decreasing relative max and min, so we'll take the derivative and do the plus minus analysis. Okay, so we're going to use the quotient rule here. In the denominator we'll put x minus 5 squared. Then we put x minus 5 over here. Then the derivative of the numerator, which is 2x, minus the derivative of the denominator, which is 1, times the numerator. Alright, let's simplify that numerator. Alright, here we get 2x squared minus 10x. And here we have minus x squared plus 16. Alright. So in the numerator we have x squared minus 10x plus 16. Okay, remember we want to see where this is equal to 0. This numerator factors x minus 2, x minus 5, x minus 2, x minus 6. Sorry, x minus 2, x minus 2, x minus 8. Okay. Alright, so f prime is 0 at 2 and at 8, and the denominator is 0 at x equals 5. So to do a plus minus analysis, we put the zeros of the numerator and the denominator on the number line, because that's where f prime can change from positive to negative. Alright, so let's do that. Okay, so we put 2, 5, and 8. Alright, so here's 2, here's 5, and 8. 2 and 8 are in the domain, and 5 is not in the domain, so 5 is not a critical value, but we need 5 in the plus minus analysis. Notice the denominator is always positive or 0 because of the squaring over here. So when we do the plus minus analysis, we're only going to substitute into the numerator x minus 2 times x minus 8. So if we put in 9 to the right of 8, we have positive times positive. Okay, here let's substitute in 6, for example, and this will be positive times negative. And here if we substitute in 3, we have positive times negative again. That means f prime is negative here. If we substitute in 1, we have negative times negative, which is positive. Okay, so this tells us that f is increasing on the interval to the left of 2, decreasing between 2 and 5, decreasing between 5 and 8, and increasing to the right of 8. Okay, so from this picture we see that 2 is a relative max. Okay. And that 8 is a relative min. Let's get the corresponding y values. If we substitute 2 into f, we get 4. In other words, this is f of 2, not f prime, f of 2. That's a point on the graph. And if we substitute in 8, we have 16. So that's f of 8. Okay, let's look at the next example. Okay, I wrote it over here. And now we're ready to differentiate. So we have f prime of x and square the denominator, and then write the denominator x minus 2 over here. Okay, we're doing the quotient rule. Derivative of the numerator, that's 2x minus 3. And then subtract the derivative of the denominator, which is 1, times the numerator. Okay, let's just simplify that numerator. When we multiply everything out and simplify, we have, well, let's say we do it up here. Okay, foiling this out, we have 2x squared. And for the middle term, minus 4x, and a minus 3x is a minus 7x. Minus 2 minus 3, that's plus 6. And now distribute this negative, opening the parentheses, we have minus x squared, plus 3x, and plus 4. Okay, so here we have 2x squared minus x squared, that's x squared. We have minus 7x plus 3x, that's minus 4x. And 6 plus 4, that's plus 10. Alright, to do the plus minus analysis, we look for zeros of the numerator and denominator. Now, if you try to factor this, you'll find that you won't be able to factor this. It doesn't factor. So then you can go to the quadratic formula. But before you do the quadratic formula, it's really best to do the part under the square root first. That's called the discriminant. And check the discriminant. If the discriminant is negative, that means that this has no real solutions or no zeros. Okay? If this has no zeros, that means that this is either always positive or always negative. So let's first just calculate the part of the quadratic formula underneath the square root. Again, that's called the discriminant. And that part is b squared minus 4ac. So b squared, that's minus 4 squared minus 4ac, 1 times 10. So that's 16 minus 40, which is negative. Alright, so that implies that we have no zeros from the top. No zeros or no roots. So when we do our plus minus analysis, we only put the 0 that's in the denominator, the 2. Which isn't a critical value, it's an asymptote. Alright, now if you substitute in something to the right, you'll get, you substitute in 3, for example, into f prime, you'll get a positive value, and to the left also you'll get a positive value, which tells us that f prime is always increasing. No max mins, and always increasing. Okay, 10a is a polynomial, and we want to see where this polynomial is concave up and concave down and find the inflection points. So we have to do a plus minus analysis on the second derivative, f double prime. Alright, we'll start by finding f prime. That's f prime is 3x squared minus 5x minus 14. And let's do f double prime. 6x. Sorry, this is plus. This is positive here. Okay. 6x plus 5. Now we want to know where is this 0 for our plus minus analysis, and that is 0 when x is equal to minus 5 over 6. So we put that on the number line, just minus 5 over 6, and that's a critical value. And substitute into the right of minus 5 over 6, like if we put in 0, we have positive. And if we put in something to the left of minus 5 over 6, we'll get f double prime is negative. So here f is concave down, and here f is concave up, and this is an inflection point. So the inflection point is at minus 5 over 6, and you substitute into f of minus 5 over 6. Okay, let's look at 10b, another polynomial, and we need the second derivative again to see where it's concave up and concave down. So first, the first derivative, that's 4 times 3, that's 12x cubed, plus 12x squared, plus 12x. Okay, let's just factor out that 12. Okay, and now let's do the second derivative. So we keep the 12 out there. We have 3x squared plus 2x plus 1. And we want to see where this is 0. And if you try to factor this, you won't be able to. So we'll go to the quadratic formula. And before, again, let's just do what's under the square root, b squared minus 4ac, the discriminant. Because if the discriminant is negative, then we know that this quadratic has no zeros, is never 0. So b squared here is 4, minus 4a is 3, and c is 1. That's 4 minus 12. That's minus 8. All right, negative. And since it's negative, we know it's never 0. So we have no zeros to put on the number line at all. And the plus minus analysis would just look something like this. Just one interval. Substitute in one value, like 0 for example, and you have positive, f double prime is positive, so it's always, f double prime is always positive. And that means that f is always concave up. No inflection points, and always concave up.